Hi, this is Ingo from RapidMiner. Today I would like to discuss something which I personally find extremely exciting, although you will see a little bit later that most people don't really share this sentiment. And it's data preparation. I think it's an incredibly important part of the machine learning and in general data science process. But in fact, the way how we're doing this is not is maybe not just good enough. It's taking too long. We spend too much time on this, and it's not a very smart approach. So today, I would like to introduce something new to you, and I hope you find it as exciting as I do, and it will change the way how you will do data preparation in the future. So let's get started by setting the stage and think a little bit about what is the really underlying problem, and why would we need to focus and think about this in the first place. And the problem still is that most organizations still face a data scientist bottleneck. People want to do data science, they want to use machine learning models in production, but they can't achieve this just because they don't have the necessary resources for this. And although colleges and everybody else tries to create as many data scientists as possible, it's just not fast enough, and it's hard to hire them and everything else. We all know that. So this is the problem, and a potential solution really comes with two different flavors, but they can maybe be solved at the same time. And one potential solution could be, let's empower more people to do data scientist work. So that means obviously we need to make this a little bit more, well, a little bit simpler, because data science in general and machine learning is just too hard. And if data preparation, and we'll see this in a second, is such an important part of data science, also we need to make that simpler as well. And then the other element to this is, even if we simplify it and everything else, let's also make sure that the resource we currently have, or we are going to hire in the future, are more productive. So how can we actually accelerate this whole thing like big time? So you can think of this almost like two sides of the same coin, but it is important to understand, like, it is still a problem, and we can only overcome this problem by empower more people, and the people we do empower, or we already have, make them more productive. All right, so now, well, how does data preparation actually play an important role here? We all keep saying that more than 80% of our work as machine learning experts and data scientists is preparing the data, and I personally feel it's actually much higher. But here's some data sets from somebody who did a survey among data scientists and in general analysts, and how much time do they spend on the different aspects. And in fact, the big blue part here is cleaning and organizing data, and that's 60%. And then the light gray part is collecting data sets. It's another 19%, so that's already 79%. And even building training sets, the orange part at the bottom, at the top, it's another 3%. So in total, 82% of our time we spend on data preparation, and only the 9% plus 4%, like 13% on actually doing the modeling work, and then other stuff, the other 5%. So my point really is, we spend more than 80% on data preparation. That's probably because we love it so much, right? We're so excited that we can do data prep, that's why we spend so much time, but actually not. If we ask the same people, well, what is the least enjoyable part of data science? Well, 57% say, well, it's actually cleaning and organizing data. That was the 60% bucket we have seen before. So we spend 60% of our time on that, in that bucket, and that's the one area we enjoy the least. But then even collecting data sets and also building training sets, the other two elements of this, which form the total 82% of where we spend our time, is in the top three of least enjoyed things. So we spend 80% of our time there, and then we don't even enjoy it. I mean, that's horrible. But that's reality. So why is that? Why do we need to spend so much time, and also why is it really not that much fun? And I think one way to think about data preparation, but in general data science, is to have a look into the different approaches to data science. One is the code-based approach on the left side of the spectrum here, and then there is the data-centric approach on the right side of the spectrum, and then there's something in the middle, which is a process-based approach. Let's quickly discuss all three of them. Code-based approaches to data science are pretty much the norm, and I'm not saying this is actually a good thing, because I love coding and I think there's always a place for coding, but if you keep solving the same problems over and over again by writing code, you're doing it actually wrong. It's just not the most efficient way, and it's not something a lot of people can do. But the beauty about writing code is it's so powerful. You're so flexible. You can basically solve whatever you want to solve, and that's amazing. That's definitely a huge plus. But then again, learning programming language like R or Python is a little bit more hard. It's difficult. It's not for everybody. But another thing on the plus side, though, it is repeatable. After you wrote the code, you can apply this code on the same data over and over again, and you're supposed to get the same results. So that's the one end of the spectrum. The other end of the spectrum is a more data-centric approach. And to say one word to make sure that you understand what I mean with this, it's Excel. You look into the data, you change the data, you edit the data, you constantly work directly with the data, and that's fantastic because that's a very intuitive approach. You immediately see the impact of your changes. Unfortunately, that also makes it a little bit more limited. So for example, it's very hard to do things like loops or branches on this data with this data-centric approach. So that's not really solving all the problems. But it is very intuitive. A big drawback, though, is if you do 10 different things on your data set in Excel and then you show me the final result, I couldn't tell you then, but just looking at the resulting data, what it is you did. And that's a bit problematic. Often those data-centric approaches are not repeatable, and that often comes with problems for data governance as well, and also making sure that you can apply the same approach to new data. So those are the two ends of the spectrum, and then it shouldn't come as a surprise that the process-based approach, something we at RapidMiner has been doing for a long time, is kind of like a balanced approach in the middle. It's especially if you also allow to embed code, it's as flexible and powerful as coding, but it's definitely a little bit easier, a little bit more intuitive than coding. Maybe not as intuitive as the data-centric approach, but yeah, it's balanced. It's somewhere in the middle. It's typically good for governance as well. So if you have a process and this process can be applied on new data sets, it can be shared with others, other people can check it, everybody can understand it. It helps you with your governance around machine learning and data science. But there is also one drawback, and although we are big believers in processes, I would be lying if I wouldn't point this out. Even if you design processes, and it's typically a little bit faster than coding, especially after you're getting used to this, and the reason is because every step in the process it can encapsulate like 50 or 100 or 200 lines of code. So you can do more things quicker. But it still requires you to think a little bit like a programmer, because if when you code, you write code and then you interpret it or you compile it and apply this code then on some data, and then at the end you see the result. But while you're creating the code, you need to envision what this code is going to do to your data. And that's actually still true for processes as well. That's a drawback. So while you're designing the process, you can't see the result until you finally execute the process, and only then you see if you made errors or if everything is good. And this is what makes it so hard. And also, even if you're following a process-based approach instead of a code-based approach, makes it also take longer than it's necessary. And it's not for everybody. For the same reasons why coding is not for everybody, thinking like a programmer still is not for everybody. And that's the problem. I mean, this is a research which is interesting for us as a data science platform vendor. Obviously, the most important thing is usability for most people. And it's not vendor validation or total cost of ownership. It's not even the functionality of like how many machine learning models do you support or anything like that. And that makes sense if you think about this big data scientist bottleneck we discussed in the beginning. If you want to empower more people, then usability becomes the most important thing. But at the same time, even with a process-based approach, you can't get the full 9 yards. You can't go the full 9 yards. You can't get all the way to empower basically everybody. So what could we do differently then? And we have been thinking long and hard about this. And I think one way of actually combining the best of both worlds and getting to the ease of working directly in data, but at the same time keeping the advantages of code and process-based approaches, is by turning things around a little bit. So often people think we start with code and then we encapsulate the code in processes and then you can apply the process on data and then you see the result. But that whole way of thinking might be wrong. So let's forget about code anyway. It's definitely important for certain people. I love it myself, but not for everybody and not for every solution. So let's drop this one, but then let's turn around the data and the process. What if we actually work in the data, and then depending on what you do to the data, we build the process in the background? It's almost like it's like working with Excel, but then all the changes you do to the data, it's almost like it's recorded like a video, and then it's turned into a process which can be applied to new data, and you can always follow along and make sure that you did no mistakes and everything else. And this is really a paradigm change. And I think personally this is exciting because I believe in the future this is how people will create data science solutions and will work with data preparation, because it combines all the advantages of the different approaches. You get the ease of use of a data-centric approach. But since we build processes in the background, You keep all the advantages of governance and repeatability, and even you keep the power, because then you can still edit the processes and make changes to the process if you have to. You can even embed your own custom code if you have to, so you're not losing anything. But just by turning things around, you really get the best of both worlds. And I think personally, this is absolutely exciting, and so it's an honor to introduce to you now RapidMiner Turbo Prep, which is doing exactly that. So the whole vision of RapidMiner Turbo Prep was to provide this interactive, very data-centric way of working with data, like sitting in Excel and changing the data directly. So you do all the blending and data cleansing directly in your data, but then we record what you did in the background and we build those processes which can then open up. And that will also, at the end, we will discuss this a lot around the whole notion of that we can't accept black boxes. It's so important that you're not hiding what you did, even if you automate things or if you work in this data-centric view. So building process in the background is important for keeping those advantages, but it's even more important because otherwise you can't trust those results really. It's doing a couple of more things. So first of all, it offers a lot of automatic ways to improve the quality of your data, specifically for machine learning. It's seamlessly integrated with auto model, again, helpful for machine learning. It scales to really large data sets. I mean, although it is data-centric and very interactive, you can actually work on pretty large data sets as well, and still will feel good, and you don't need to wait too long. And since we turned this whole thing around and have this paradigm change, it's supposed to be usable by literally anyone who can. If you can use Excel, you can use the RapidMiner Turbo Prep. Okay, so for the rest of this webinar, I would actually like to go into the product and show it to you and go through two different demo scenarios so you can actually get a feeling how this whole works, and I hope that actually makes it much clearer than me going through hundreds of slides and trying to explain all the details. So we will have two demo sessions. After each demo session, I will summarize what we saw in each session, and then at the end we will discuss a little bit more why those pros and the black boxes approach or no black boxes approach is so incredibly important. All right, so first demo session, I'm going to use the good old Titanic survival data. I mean, it's data about the passengers of the Titanic, 1,300 people. And typically at the end you would build a machine learning model predicting who's going to survive. In the interest of time, we're not going to do this today though. But we can still analyze this data a little bit, and we can work with the data and do some data preparation towards this goal of understanding what was going on back then on that ship in 1912. All right, let's go into RapidMiner. So this is what you typically see whenever you start RapidMiner. This is version 9.0. And well, one way of starting using RapidMiner is clicking here on blank, which would start the process designer, and you could build processes from scratch. But obviously today we are going to look a little bit more into Turbo Prep. So you could basically click here on Turbo Prep to get started. You could also click on this button here at the top wherever you are to go to Turbo Prep. So on the left side here, we actually will add a couple of data sets. In this case, we will start with only one data set. It is the Titanic data. You can pick data from everywhere you want and from your repositories. Well, whenever you select a data set, you see some information here on the right side. So we're going with the Titanic data. By the way, don't do this now. I think I would recommend to follow along this webinar first, but you will get access to a recording later on. And if you would like to follow along then with this webinar and do it yourself, I highly recommend that actually. You will find this Titanic data set in the samples folder, and I will tell you for the next demo session, we find those data sets which are directly included in RapidMiner 9 as well. Anyway, so we go with the Titanic data. Let's just load it in. So the first thing we see is we have those 1,300 rows here, 12 columns, and we see the complete data set. So you can directly start working with your data right here, and I will show you how this is done. Another thing we will spend a little bit more time with later on are those little quality measurements and the distributions here at the top. Those are really helpful if you want to improve the quality of your data. So for example, this blue column here, this is pretty much behaving like an ID, which means that almost every name is only occurring once, which is a characteristic of an ID. And often this type of columns are not very helpful for machine learning models, and you often would like to get rid of this. So we highlight this kind of things, but more about this later. If you want to learn more about the different columns, you can always show the details for each column and actually browse through them. So here, for example, we have 20% of the age information is missing. So you get some statistics, distributions, and everything else here as well. All right. So now let's actually change the data, and all the changes we do, they fall into one of those 5 groups here: transform, cleanse, generate, pivot, and merge. And in this first session we will start with transforming, do a bit of generation and pivoting, and let's see what we can learn from this data set. So first thing I would like to do is start a new transformation session. So you just click on transform, and now what you do is always the same thing. You basically select a column you would like to work on. So for example, I would like to work on this sex column here. I'm certainly not a prude, but the word sex, I don't know, it has a bit of a connotation to me. Maybe we should rename this whole thing if you want to use this later on in some report. Let's call this gender. That sounds so much more sophisticated. All right, so you select a column like this one here, and then on the left side, you can see all the things you can do through this column. And the first one is the renaming. That's exactly what we want to do. You could change the type, you can remove the column, copy it, you can filter it down according, let's say, keep only the males, only the females here, sorting it, and all other kinds of things here. All right, so here, let's do rename. Let's call this whole thing gender. And if I think this is good, I can apply this change, and we can see, yeah, now this column has been renamed to gender. All is good. So you can undo this change. Obviously, we're not going to do this. But one thing is important to understand. While you're working with your data, nothing happens immediately. You kind of work on this, and you kind of at one point need to lock the results in by committing this transformation session. And that's a very useful approach because it allows you to actually very quickly work with your data, make sure that everything is exactly how you want it to be, and only then at the end you commit it. If you press cancel, you would just go back to the original stage and to the data set in the state it was when you started the transformation session. So here in this case, I obviously want to commit it. I like this result, so this is good. All right. So next thing I would like to do is have a look at these two columns here, number of siblings or spouses and number of parents or children. So apparently those are about family size, but somebody divided the family into those two subgroups here and created two columns. I actually would like to bring it back into one column, and for example, for Miss Elizabeth Walton Allen here, I would like to create her family size on board, which is, well, she was traveling apparently alone, which is basically the sum of this column, plus 1 for herself. And for example, the next 4 people here is a family of 4. Again, for all 4 people, I would like to build the sum of those two columns plus 1. So I would like to end up with 4 for all 4 people here. And this is done by generating a new column. Apparently, we have a whole group for this. So let's click on this generate here. And we can now use this new drag and drop interface to create a formula for this computation. So first thing we do is give this whole thing a new name, family size. And now you can simply drag the columns in. Like for example, this one here, and then I add a plus, and this one, I add another plus, and also note that we constantly check the input. So for example, right now I say plus, but what am I adding here? So I didn't edit, so there's apparently a mistake, so I need to make this formula correct. And only if it's correct, and if I also define a name, now I can actually update the preview. And this is the final step to make sure the formula is not just syntactically correct, but it also delivers the desired results. So for example, for this first person here, we have the family size of 1. Yep, we checked that before. For the next 4, we have the family size of 4. That all makes sense. It looks correct. And it's pretty simple. Even if you use a lot of columns, in green you see all the columns which have been used by this calculation, and in purple you see the generated columns. So this all looks good. And like before, in order to lock in this result, we need to commit this generate, and here we go. Now we have this new family size column. We no longer really need those 2 columns here. And one way of getting rid of this, you might remember in the transform group we had one action called remove in order to drop those columns. But this is one way of actually getting this started, first going to the transformation group and then doing this. Another way would be you could select the columns you would like to work on and then do a right click and just select remove here, and they would be removed. And this is what I mean, it's a data-centric way. So you can directly work in the data either by starting those sessions manually or directly change the data. Even nicer actually, there's another way, you just select them and press the delete key. And what happens now, we automatically start a transformation session for you. We have the 2 columns pre-selected. Also the remove action is pre-selected. So all you need to do is press the enter key or hit apply here, and then those 2 columns are gone. So you still kind of like have one last chance to check if this is really what you want to do. But again, you could press cancel otherwise. But in this case, yeah, that's the desired result. Let's log it in. So that data set looks a little bit nice already. We have a new column here. We renamed something. Before we go to the next step, let's actually make sure that this all makes sense. And there's one way of doing this. You can always open up this history here by seeing the different steps. And you could even roll back. So even if you later say after a transformation session has been committed, I would like to go roll back before this step, you can select this step and click on this button here as well. But it's also just a nice overview so you can see the different steps. All right, so now let's actually do some simple analysis here on this data. And one really powerful tool for this kind of thing is the pivot group. And you might be familiar with pivoting or aggregation tables, also from Excel or from BI tools or data visualization tools. So let's go into the pivot group here. And it's a nice drag and drop interface to define what you would like to see. And let's answer a couple of questions. So for example, the first question could be, what was the average family size for all the passengers there? And maybe later on we could also wonder what was the largest family on the Titanic. So this is actually an aggregation. So we would like to calculate an average function. And one way of doing this, or actually the only way of doing this, is to take the family size here and drop it down in this aggregates area. And in this particular case, since it's a number, average would be pre-selected, and we see immediately the result we've been looking for. The average size of the families is 1.884. Well, what about the maximum? We could drag in the family size a second time. We can also just click on this little box here down here and just change the function, for example, to maximum. And if I do that, we see maximum, yeah, that's good, and the maximum family size was 11. Well, I mean, keep in mind 1912. I guess family sizes have in general be a little bit larger. Although 1.884 average isn't really that different from what I guess it would be today. Anyway, that's not the topic for this webinar. So let's change it back to average and let's actually do some more analysis. Another thing we could do, for example, is try to figure out if the family size is different for the men and women on the Titanic. So you could easily drop in the gender, the renamed column from before, just into this group by. You could also do it in the column grouping, it wouldn't really matter, but let's just drop it here. And now we get a new data table with 2 rows and 2 columns, the 2 rows for the female and the males, and then we get the average family size for those 2 groups. And we can indeed see that while the overall average was 1.884, now women have been traveling with larger family sizes than men. And again, I'm not 100% sure if that would be that much different today, but this was more than 100 years ago, and I think it was just less likely that women have been traveling alone from Europe to the United States. Maybe if they had family over there or whatever. And we definitely actually saw one data point already in the table before, Miss Allen, who traveled alone, but I think it was just like a little bit less likely. Okay, anyway, so yeah, we can see that. Now another thing, since this is about the Titanic, obviously we have the survival column here telling us if the person survived or not. We can also see, like, well, is there any difference between the men and women and also their family sizes depending on their survival status? And we could drop the survived also here into the group by. Another nice way is actually creating this kind of like a cross table by dropping it here at the column headers. So now we get, that's actually a real pivot. If you do something like that and build this kind of cross table here, now we get the 2 rows from before, but now we are basically having those 2 columns for people who did survive and people who didn't survive. And interesting, if you look at the second row, the difference in family size is not that large for men. So it was pretty much the same. But for women, it was indeed different. So women who did not survive the Titanic accident have in fact been traveling with a larger family size. So that already could be a bit of a first hint what was going on there. And we are not going to do this on this data set. We will model the other data set a little bit more, but this data set, let's skip this for this time. But if you would do this and build just some machine learning model on this, you would indeed see family size just didn't matter as much for men as well. The gender is one of the most important things for survival, and if you've been a man, you pretty much have been doomed back then. And by the way, women and children first is still a nautical rule even today. But for the women, the family size actually had a huge impact. And if you had a large family as a woman, you had a lower likelihood of survival, in fact. All right, we don't need this result, so I could cancel it. I could also just commit it. So if I do commit it, this is the final outcome. But there's a couple of things now before we summarize the first demonstration and go into the little bit more complex, more exciting other one. Well, what to do with a result like that? So we saw already the history before, the things we did to the data. We can do 2 things in particular. One thing is we can just export the data, and you can write it back into a repository or, excuse me, write it into some Excel file or something, and then just go follow those steps here to do that. So you can export the data, the final result, which is often very useful. But what is probably most exciting and very similar to this history we have seen before here is that you can also now create the process doing exactly the same things on this data set you just did to this data. And you can do this by just clicking this little process icon here. And what this is doing is it actually moves you over to the design perspective of RapidMiner, and you get a fully annotated process with all the different steps, like the renaming, and it explains to you exactly what's happening. So like here you see the parameters are set for this rename, or for removing those columns. There's actually even a whole full sub-process for the aggregation of the pivot here. So it's the full process. And if I execute this process now, you see I get exactly the same result I got in Turbo Prep. So, and that is beautiful because it makes it transparent. You can fully understand what is going on. You can check if everything is done correctly. You can also store this process, for example, on the server or in the rest of the RapidMiner platform, and deploy it or schedule it and run it on a nightly basis. Or you can share it with your colleagues, or you can turn it into a building block and reuse it for future processes. It's really important, this connection between working the data and still being able to create those processes. That is exactly the paradigm change I have been talking about before. Okay, so that is the first demonstration. Let's summarize what we've seen so far. So there's, it's very data-centric, obviously, but there's those 5 main groups: transform, cleanse, generate, pivot, and merge. We have seen transform, generate, and pivot already. We'll see the other 2 in the next demonstration. Pivot obviously is for creating those pivot tables. Merge is for everything around joins, appends. Generate is for adding new columns to your data. Cleansing is for everything related to improving your data quality, especially for machine learning. And transform is pretty much all the rest. So those are the 5 main groups. It's in the data. You see immediately how the data is impacted. You will get an immediate feedback in the preview and to make sure that the result is correct. It's easy to roll back. It's hard, even if you made a mistake, yeah, just cancel it, no problem then. But even in addition to this, if you realize later, no, that's not what you wanted to do, you can always roll back. And all the changes are recorded while you're doing them, and a process built in the background, which can then be opened and shared and scheduled and everything else. So that was the first demonstration. The other one is a little bit more complex, and we actually will end up with modeling some data as well. So this data is about predicting flight delays. So actually, let's go back into RapidMiner and let's load the data. You can just start basically a new session here by just removing all the data sets. Okay, so now we start over again. And we have this data sets here about domestic flights in the United States. So I have this locally here, but by the way, as I promised, if you want to follow along, there is in RapidMiner 9, there's this new great community samples repository here, which is pre-installed. And it's actually on one of the cloud-based servers from us. And there's this community data sets, transportation, and then there's the flights and weather information as well. So you can pick it up from there. It's, I don't know, a couple 50 megabytes or something. So I'm not loading it from there now because, well, I want to save some bandwidth here. But I take my local copy. But it's the same data. All right, let's start with the flights data. This is much larger, so this is 230,000 rows. I mean, still not massive, but it's a much larger data set, about 30 columns. You see this information here at the bottom. All domestic flights from New England airports, so Massachusetts, Connecticut, Vermont, New Hampshire, and Rhode Island, and the main airports in those 5 states. And in the year 2007, so all the domestic flights, 230,000 in total. And there is this one, so here's the airport code, the origin. There is this one column here, departure delay. That is the one we are most interested in, because as you can see, many flights are actually late. This is the delay in minutes. And at the end, we would like to predict if a flight is going to be delayed or not. But before we even get there, let's do some very basic analysis. And again, we will start with some exploration in the pivot group. First thing I would like to do is, what are actually the airports? So I can just drop in the airport code, or the origin airports here, and well, yeah, that's not even that helpful. I mean, ACK, I don't know what that is. BOS is Boston Logan, that one I do know. So let's also drop in the origin name. Aha, ACK was Nantucket. Okay, good. So now, as I said, we are interested in figuring out what are the flight delays. So let's actually create an aggregate now with the delays, and let's calculate the average delays for the different airports. Let's sort this in descending order, and you can see that in fact the airport ACK, which is the Nantucket airport, has the by far biggest delays, on average 51 minutes. That's crazy. I'm not sure if you're familiar with the area here, but Nantucket is a pretty small island here in Massachusetts, and there are probably not many flights going from Nantucket. Maybe there's a handful per week or something, and if they're delayed or not, who cares really? So we could now try to build models for the different airports and focus on something like Nantucket first, but we probably won't even have enough data. But the main point is nobody would really care about a predictive model for Nantucket. So let's actually see how many flights are going from the different airports. Let's drop in the origin again, and since this is a nominal or categorical value column here, we will get the count. Let's sort this again, and indeed, it's only 314 flights from Nantucket. I mean, nobody cares to build a model for that. Boston Logan, no surprise, is the one with the most flights, 128,000 flights in total, and still a more than 12-minute average delay. So I would suggest let's just focus on Boston Logan for the rest of this analysis here, because, well, I mean, this is a pretty high delay for that many flights, so that we should definitely build a model for Boston Logan here. I don't need this table in this form, so I can just cancel as I described before. So I go back to the original data. All right, let's focus on Boston Logan. How can we do that? We can select the origin column here, and again, right-click, for example, and filter it. So now the column is selected, and we can say I would like to only keep those flights from Boston. Okay, let's apply this. So we bring it down to the 128,000 rows now. All the statistics are recalculated, so this all looks good. Well, I like that result. Let's commit it. Now, before we even get towards building machine learning models, there is one thing I know from my own experience, and I fly a lot. Or at least I used to fly a lot, but I still fly quite a bit. Weather is by far the #1 influence for flight delays. I mean, if it's stormy weather, if there's I don't know, heavy rains or lots of snow, freezing temperatures, typically it's more likely that flights are going to be delayed. So I've got some good news because I actually do have a second data set, this weather information here. Let's just load this as well. And for this data set, I have for all the airports, for every day in the year 2007, so it's the same year, I have the weather information on that day, like things like max and min temperature, or visibility, or humidity, and so on. Like, did it rain, or what was going on that day? So I have all this weather information for all the airports and all the flights. So I would like to join those two data sets now together, or here merge. Merge basically, it's either joins, like you may know from databases where you bring different columns typically together, or it's an append where you add rows of one data set to another data set. So in this case, I'm more focused on the columns. But here's the thing. In order to make sure that we are joining the right rows to each other, we need to make sure that we are kind of matching the locations of both data sets, but also the date. So the location is going to be easy because in the weather information I have the airport code, and here we already know that we have the airport code as well, so that's easy. But the problem here is that in the weather information data table, I have the date as a proper date column, like one column with a proper date information, and here I actually have the year, the month, and the day of the month, so it's separated into 3 columns. And we need to make this match somehow. And either we turn those 3 columns now into one date column, that's definitely possible, or I think it's a bit simpler to just turn this column here into 2 columns with the day and the month. We don't need the year because it's 2007 in all cases. All right, so that is another transformation session. Let's start this one. And the way we'll be doing this is we are going to copy this column. Let's give it a new day name, weather day. And also we're going to rename this one here just for consistency reasons, weather month. All right, so now we already have 2 columns with the full date information. But here I only would like to see the days, and here I would only like to see the month. And that's pretty simple. You can just change the type, and you can change it to a number, and I would like to see the month here. Boom. And here I do the same thing, only that I say I would like to see the date. Boom, done. So now we have 2 columns here. Let's lock this result in by committing it, and we have 2 columns here, and they have the same format. So now we can, in fact, merge those 2 data sets. And here's another thing I really like about Turbo Prep, which helps you a lot if you have many data sets or lots of columns in your data. We actually use machine learning to predict how well those data sets will match and what are the best matching columns. So here we only have one other data set, but it also has a really high score already of 94. So we start with the weather data set, and the flights data set is actually a good match. Let's do some join here, And first, let's focus on the location. So here we have the airport code selected for the first data set, the weather information. And now look at this. Now again, we predict that the origin column is the by far best matching column to the airport code here, and that's exactly the column we've been looking for. Now consider if you would have hundreds of columns and the one we are looking for is at the top, that's really, really nice. Same here, if we go with the month, even if it would be some cryptic name, we could still pick the month column here just because it's sorted with like a very high match here at the top. And then finally we need to do the same thing for the day. Here we have it. And again, the day of the month is here at the top. All right, final thing is then to create a preview. Here I'll throw you join keys, they look good. In blue we have the whole weather information, that looks good as well. Then in green we have the whole flight information for all the 128,000 rows. All is correct. Let's commit this. Okay, so now two last steps before we actually do some modeling. One thing is, you have seen in the flight information we had this departure delay column, and it's the number of minutes, but I actually don't really care about predicting, oh, it's exactly 130 minutes or it's 67 minutes. All I do care about is this flight going to be delayed or not. So I would like to transform this column here away from this numerical exact minute number to something which is a little bit roughly like, yeah, it's a delay or it's not a delay. And the way how we do this is by doing another generate session here. And we can basically look for this column here, and we can drag in functions, like for example this if function. Then we add the column. Then we say, for example, well, if it's larger than 15 minutes, then it is a delay, true. And if it's smaller, that's the else part, it's not a delay. Well, that looks good. Let's call this new column delay class. Let's update our preview. Okay, 0 is false, 38 is bigger than 15, that's a true. Yeah, that looks about right. So even for the negative ones, it's a false, 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 true again, 31. That looks correct. So if you like that result, let's commit it and let's log it in. So this is the column now, this one here, I'm actually going to predict later. But we still have some data quality issues here. So for example, we have a couple of columns which are pretty stable, indicated by this gray one here, or the year, which is 100% stable because it's 2007 for all rows. I mean, there is nothing to learn from that. There's some columns which have so many missing values here, indicated by this red bar. So we can now fix all those problems and work on all those problems like column by removing them. Or you can go into this cleanse group and, for example, if the one with many missings here, there's like functionality for actually replacing the missings and removing others with low quality, duplicate handling and everything else. We could do this. But another super exciting thing about Turbo Prep is what we call the Turbo Prep auto cleansing, which brings up this little dialog here. And you can now specify, well, this is the column I would like to predict. And that's important so Turbo Prep is not accidentally taking it out if the quality is not very high, or maybe there's some missings, so the missings won't be replaced because those are typically the rows you would like to create predictions for. So you can define this. If you want to do some clustering, or if you don't care, then you can also click this button here, but often it's a good idea to define the column you would like to predict later on. Now, RapidMiner is suggesting you columns which should be taken out. So for example, because of high stability. I mean, everything is Boston. That's not helpful. Or even here for the numericals, although not everything is 16, it's really by far, I mean, it's almost stable here. This one here, this has way too many missing, so take it out. So typically it's just a good idea, just go with this, because those are really low quality columns, so you should probably get rid of this. The next two steps, I'm not going into the details, but they're useful, especially if you're not going to use RapidMiner's auto model. I mean, we will do this later, so you wouldn't need to care, but sometimes certain machine learning models, they can only work, let's say, on numerical data or only on categorical data. So you can make this choice here, and then Turbo Prep's auto cleansing will then do things like dummy encoding or discretization, binning to your data. If you're not really sure, just leave things as they are, especially if you're going to use auto model, because auto model will take care of this anyway. All right, so I'm not going to do anything here. Same is true for a numerical column. You could do dimensionality reduction using a PCA or a normalization to bring things roughly to the same scale. Again, if you don't really know, or if you're going to use auto model anyway, just keep things as they are. So we show you a little summary, what's going to happen, removing those low quality columns, replacing missing values. So now you can apply those changes. And if you do this, well, after we joined the weather information, the flight information, we had a little bit more than 40 columns, so we lost some of them. We still have all the rows, but look at the quality measures here at the top. it all looks really good. There's still a bit of gray, but that's totally fine. And now red any longer, everything is perfectly fine. So we like that result, let's log it in, and here we have it, the data set is ready for modeling. And just as a reminder, I mean, again, you can export it and model it, for example, somewhere else, or maybe that is just the result. I didn't mention it, and I'm not going to, but you can start plotting things here. You can obviously see all the changes here and roll back things. And in this case, the process we can create is actually much more complex. Look at that. There's so many different steps. And if you think about this, I was explaining this whole thing. But it has sub-processes and everything. I could have been building this process, obviously, and it might have been taking me an hour, or maybe whatever, a couple of hours. I did it in a couple of minutes, and I explained everything. I'm pretty sure if I would have been not talking, I could have been building this whole thing in a minute max. And that's why we call it turbo prep. It's so fast, and you see immediate results, and you can immediately make sure it's all doing the right things. But still, in the end, we built the processes. So that's exciting. But, well, let's now do the final step, and actually let's do some modeling. And when you click on model, we automatically switch over to RapidMiner's auto model. The data is preloaded. We obviously want to predict this particular column here, so let's click on this column. We can ignore this step. We are actually caring more about the delay, so let's keep it as it is. And now auto model is making some final quality check, and it's good that it's doing this. And this is another reason why I think you cannot accept anything black box, no black box approach for machine learning, because here what we did is we also recognize, like, wait, this departure delay column, that's super helpful to predict this departure class column or delay class column. Yeah, guess what? That's because one column is directly based on the other. And we just forgot to remove it. And if we just would go for the models with highest accuracy, this column would stay in because it's super helpful, but the models would be trivial. They're not helpful. And like, if you wouldn't be able to see that, that's a sure recipe for disaster. Because, I mean, you would use information you don't even have at the moment of time you're doing the prediction. So long story short, it's important that RapidMiner points it out. This is a very suspicious column, and that's why you should probably take it out. But sometimes you're just lucky, and it's just a helpful column, and you can keep it in. But in this particular case, it has to go. So auto model points this out. Thanks for that. And well, suggest to use those two models. I add another one. Just why not? Logistic regression. Well, it won't take too long. I mean, it's only 130,000 rows. That's not particularly big, but it might take a bit. Maybe you should not do gradient boosted trees with automatic optimization because that could run for an hour or two. Too long for this webinar. Anyway, let's run this whole thing. Now, RapidMiner is building machine learning models, tries to optimize them. First model is already done, naive Bayes. You can go to the models and actually visualize the impact of the different attributes here. You can see which model performs best. So naive Bayes was okay, but GLM, generalized linear model, is better. Logistic regression is also 90%. Looking at the ROC curves, indeed, you want to be at the top left. Logistic regression is the best one, the green curve. So let's go into this model here. One thing which is really nice is the simulator. I mean, this is about turbo prep, so I'm not spending a lot of time here, but to give you an idea how this all works together. So you can see that with those settings here right now, it is more likely that the flight is not delayed, 75% likelihood. But I could, for example, let's do something. Let's reduce the visibility. And you can see that actually brings the likelihood for delays up. Let's also change the humidity a little bit. I don't know what. Oh, more wind. Oh, yeah, let's add a storm. What happens if we add more wind? Ooh, good, good, good. Temperature. Oh, look at that. Let's make it freezing cold, and this has a huge impact actually on the predictions. Anyway, shouldn't come as a surprise, but you can simulate it, you can optimize it, and everything else. So if you like one of those, again, like with Turbo Prep, you can always open the process which has been creating the full model, and again, it's fully annotated. You get all the pre-processing, you get how the model was built and validated, and that's the beautiful thing about this whole approach. It's not just making you fast and it's automated, but it guides you also, and it tells you what you should do. It always allows you to override those decisions, but you can always see exactly what was happening and can use this as a starting point or deploy it or apply it on new data sets. So it's as I said, it's a paradigm change, but it really brings together the best of all the worlds. All right, let's go back to the slides briefly, and first of all, let's summarize what we've seen in the second session here. So we focus a little bit more on those machine learning-oriented quality measurements like stability, IDness, missing values. So they're constantly updated, so you can work towards improving your data quality for machine learning models. There is little things I really personally like a lot is those match scores for the merges or joins. Basically pointing out, well, those are data sets which would match very well, or within the columns, if you have hundreds of columns, here's the column which actually matches best the column you already have selected for the other data set. Super little useful thing actually, and I just love it, using machine learning also to make our life a little bit simpler here. It's really easy to work with your data. I mean, we saw, for example, it's a pretty complex problem working with dates and everything, but it actually is kind of simple here in Turbo Prep. I mean, you select the column, you turn it into two columns, then extract the month and the days, and all the type transformations are done automatically. So it's pretty cool. Auto cleansing is my go-to method at this point. I'm no longer cleaning data myself at all. Why would I? Whenever I build a model, I always let auto model and or turbo prep doing the preparation for me. I mean, I can always see what happens. I can always change things if I want to, but as a benchmark, as a starting point, it's a fantastic tool to get to much better data sets and often much better models in a couple of clicks, really. And as we have seen before, the results can be exported not just as a process, but also the data itself, and it's seamlessly integrated with the auto model. So you can really, I mean, you saw the flight data. I mean, we merged multiple data sets, we cleaned it up, we created a model, and that all is done in less than 5 minutes. That's pretty cool, actually. Let's wrap this whole discussion one last time to get rid of one misunderstanding. When I talk about black boxes and other people talk about black boxes, unfortunately, there's some misunderstanding out there, and I would like you to understand fully and embrace fully what this misunderstanding is and make sure that you're avoiding the right thing here. When I talk about black boxes, I'm not so much concerned about the black box, which is the model itself, but I'm concerned about that in many solutions out there, the way how the model was created or how the data is changed is opaque to you. You don't know. You just can't see it. You can't see the details. You can't control this process, and that's a sure recipe for disaster. And that's in particular true if you separate the data preparation from the model building. So if you have a couple of data engineers doing some data prep in one tool and then you do the model building in another tool, what you can no longer do is actually measuring the impact of the data preparation on the model quality. And if you're not measuring this, the model might look too good, and it typically will look too good, and you get an over-optimistic estimation of how well the model will work. Then you put it into production, and there's really a negative surprise down the road for you. So that is just not acceptable. So just to make sure that we all talk about the same thing, there are actually two types of black boxes. And most people, when they think about machine learning and black boxes, they only think about this type one of black boxes, which is the machine learning model itself. And that is not always the case. So for example, if your machine learning model is a decision tree, that's typically not a black box. It's easy to understand it. It's also easy to explain why a certain prediction was made. But things are different. Let's say if you're looking into an SVM model, a support vector machine model with a radial basis function or a neural network, or some ensemble methods, even if they are decision tree based, like gradient boosted trees, you can no longer easily understand how a model is coming to its decision by just looking at the model and deriving some explanations. And that, yes, that is one type of black box. And that doesn't mean it's always a problem. In fact, in many cases, if you can't explain why a prediction is made, but you can still prove out that the prediction is good and that the model is correct and has been correctly built, then this is totally acceptable in many, many use cases. You don't always need to get rid of this black box, okay, which is the machine learning model itself. But then there is the model creation process, and that includes the data preparation. This is what we call the black box type 2. And here's the thing. While black box type 1 sometimes is not acceptable, but then there's tools around that. So for example, if you have a deep learning neural network, there's something called LIME, and RapidMiner is, by the way, a pretty cool implementation of this LIME algorithm, or a variant of the algorithm itself, which can then take the model and create the predictions and also explain how this prediction was made and what have been the most important influence factors for this particular prediction. There's all kinds of tools around that to overcome the hurdles with black box type number 1, and as I said, sometimes not even a problem. But for black box type number 2, people somehow believe, oh, it's automated. Well, let's just take the model. It looks like it's 98% accurate, so it has to be good. And they just accept this black box. And this is, in my world, is never acceptable. Because if you don't know how exactly the model was created, how the data was prepared, if the data preparation was correctly validated, was the model actually correctly validated? And it doesn't matter if people say like, oh yeah, well, we are Kaggle grandmasters and our tool is doing this right, or oh yeah, we have 35 publications in machine learning journals. So do I. And I still make mistakes from time to time. So it's important that you cannot accept this black box type number 2, that you have access to the full model creation process, including all the data preparation, to make sure that what's happening is actually the right thing and the desired thing, and that there's no mistake has been made, and it's important for governance reasons as well. So it's never acceptable to have a black box of type number 2. Black box type number 1, sometimes it is. Black box type number 2, never. So I think this is really important, and I want to spend a minute on actually going a little bit more detail there. So, a couple of key takeaways. Turbo Prep is a super fast way of working with your data, preparing your data. That's why we call it Turbo Prep. I also think it's kind of a fun way because you see the impact right away. It's so much more fun than actually building a process first or even coding first and then seeing the impact afterwards. And because of both, I think it's truly usable by anyone. I mean, if you can use Excel, you can use Turbo Prep. So you work directly in the data with you're getting real-time previews. There's a lot of automatic data transformations, like think about the auto cleansing, specifically for machine learning. So that's a huge time saver as well, and typically improves the model quality big time. And whatever you do, all the processes are built in the background. While you're working there, you can always open it. You get the full transparency. There are no black boxes because, keep in mind, black box type number 2 is never acceptable. It's a sure recipe for disaster. Don't do this. And with that, I think I've wrapped it. Thank you very much.